screwing me over here. Hey, I'm recording Coffee Compiler Club. Very short staff meeting because Gmail is still screwing emails. I can't get the invites sent out. Here today to talk about compilers and language runtimes of any kind. And I guess Ryan and I are going to go back and forth a little bit on concurrent hash tables. Everyone's going to be recorded. You show up on YouTube in a few hours. That's the end of the starting spiel. Okay, so going back to our prior conversation, I'm going to fill in a little bit. Ryan and I are going back and forth on basically a concurrent hash table and can you do it with locking or non-locking? And I'm talking about non-blocking hash map, which has no locks. And Ryan's talking about a C implementation of a concurrent hash table. And we're arguing about when and where you have to allocate what properties you want in a hash table. Okay, so go, Ryan. You're just saying I have these properties and can I have
Right.
them or not or
So,
what?
yeah. So basically what I'm saying is like I have I want to put an object into the map, right? And it's concurrent. And so the reason I said that I need to allocate, to do the hash map is that I have a large object, right? And so if I don't allocate, like I can't get the large object quickly atomically from that hash table. And like you could store it somewhere in like a storage region, but if you then do a resize, then you have this property that the address of the object would change. And that creates this problem, right? Where if I want to like
So,
have a
so
thread,
there is a solution and it just has a different look to it that you haven't looked at maybe. So I don't store the objects generally. I store a pointer to the object in the table. The object never moves. It's where it is. There's a pointer to it in the hash table, and the pointer can be moved atomically, and it is in fact updated and moved atomically.
okay, and then now we're allocating again because you have to
No,
allocate the pointer. Like
no.
how where are you going to put the object then? You don't
Okay,
allocate.
yeah, you had to allocate space for the object.
Hmm.
Just like you're saying, I have a large object, I had to put it somewhere, you allocated space for it somewhere. Wherever space you put it, that's where you did it. The
So
hash
my
table doesn't own the object and doesn't manage its lifetime.
so my argument here is that if I'm going to allocate anyway, it is better to do so inside the container because like let's say I have a vector in C++, right? And this could be true of any data structure, but it's easier with the vector example. I don't allocate per object I store in the vector. I'm allocating like once for a region of
Right.
objects.
That,
Obviously, you
that's
can't do this in Java, but
you can, and people do. So
doesn't Java do a memory allocation per object? Like if you have an
yeah.
array of
But I make an
objects.
array, and then I put things in the array, and they consider the array of like ints. I make one big array. It's just like a vector in C++. It has
But
ints in it.
if you have a vector of objects, it's not going to do that. Like in C++,
No, no. The vector of objects, you get one per. Although, well, implementations do what they do under the hood, but the semantics are yes, you have essentially got an allocation per object. Yep.
yeah, but in C++, like if you have a vector of objects, right, the objects
Yep.
don't have a separate allocation for each object. It's still
Yep.
an array. And this is, I think, like from a philosophical perspective, I want to store values in containers, because if I don't store values in the container, then I have to do an allocation per object instead of like the container is going to do a large allocation that'll store multiple objects,
Right,
which
right.
saves
There's a way to
memory.
do a bulk allocation to get a lot of objects. I do that in Java as well, but I step outside the Java model to do that.
Yeah, and so
Arenas, slab, resource pools, goes
Yeah,
by many names.
yeah, right,
yeah,
exactly. And
and,
to
and
do
so
it
I
for objects, I'll do in Java, I'll do struct of arrays versus array of structs. And I'll just put a wrapper around it and you'll never know. It'll look like a struct except for the pointer lifetime management. And
yeah,
that's the go-to. Actually, a lot of people do that. That's a standard go-to when you have this kind of problem.
and so anyway, I was
Okay.
thinking that for my use case, right, I also want to like load the object pointer and then access it, and then I want to be able to have other threads put things in the same map, and if the object moves from one memory location to another, that would be a problem. So the map has to be stable, as we say, which is to say that elements like a pointer to an element remains valid as long as the element is
Yeah.
inside of the hash
This
map.
is this is true of the table I'm talking about. The except the object's not owned by the table or in it, just a pointer. The pointer is your problem. The object's lifetime is your problem. The table just has a pointer, expects the pointer to be stable as well. You can add, subtract, multiply, and divide the pointer however you do that. But
Right. So if I take a
there's no
lock,
lifetime
right?
issue there.
So let's say that my hash table it has regions that are sharded, and it can potentially have like an index where it's like here's a pointer to the
So you're
node.
proposing a solution and then going to point out problems in it? Because that's not what non-blocking hash map does, and it doesn't have this
I
sharding
I
function.
I, I wasn't using a non-blocking hash map. Mine is
Oh,
a sharded
yeah,
locked hash map.
yeah,
Like it's a locking hash map with multiple mutexes, so it
yeah.
has like
Concurrent hash
16.
map is the Java concurrent hash map is a sharded hash map,
Yeah.
and you don't have to block on a read, but you do on a write.
So my argument essentially is that um the locking mechanism, if you're going to allocate anyway, to like if you need to allocate the object, you might as well take the lock. In like I do get that there's like a little bit
Okay,
of a
yeah, right. So let's back up for a second. In non-blocking hash map, you're not going to allocate. You have allocated an object maybe once, maybe you allocated years ago, maybe you allocated in bulk. When you go to the hash table, it doesn't lock. I mean, it doesn't lock and it doesn't allocate. It just casts a pointer into a slot in an array. So
sure,
there's
but
no
but if
allocation
but
for
you
the
have to
table per se.
allocate, maybe not for the table, but for my use case, I still have to allocate the object
Okay,
somewhere.
if you have a
So
use case where you allocate, you do. Although if you have a large count of threads, the allocation costs are typically sharded. And so every thread independently allocates, but if you have a lock point, then they do compete on the lock. So as soon as you go non-blocking, you'll get less contention also.
I'm also sort of confused because like even if the objects are like allocating, they might be allocating from their own like thread local allocator. So it doesn't I don't know if these two
He's
things
got
like those two factors like point at each other
he's
exactly.
got an issue where he's thinking that since he has to allocate, and allocate is expensive because whatever he's doing with an object, he's allocating it and then he's putting it in a hash table. So the active allocation to make the objects, so make the objects allocated, that's expensive because allocation. Put in the table is a lock now. Why not have it be a lock? Because I've already paid this big price, so another price in the lock is like, yeah, whatever. And separately, there was a comment that you made, Ryan, that said, oh, you have to allocate to put it in the table if you're not locking, and that's not true. So whether or not you want to lock or not, or whether or not you want to allocate or not is different. Non-blocking hash map does not allocate and does not lock, and is provably scale free, whatever. No limit on scaling. It's independent of all other things. It's whatever the parallel cache line RAM model of the theoretical universe that actually all hardware implements.
right, but the object is so I have like objects that are larger than fit in a hardware atomic, right? So
You have big objects you have to allocate for. That makes sense.
I mean, I can store them directly. Like you can make a standard atomic of an object that's, 400 bytes, but there's a secret mutex, right? Like it's not
Right.
actually atomic at the hardware level, so the
Right.
implementation is creating a mutex for you, right?
Right. Right.
Um,
I claim that's not a very wise or it's not a very performant solution, but okay, whatever. I wouldn't hide that one from the end user. I'd say you can't do that.
well, you could check if it's like there's like atomic is lock free, so you
Right,
could
right,
check
right.
if
Now
your
you have
type
several
is
different implementations. Okay, you do. Fine. I'm just saying, okay, you could, but instead of saying I could do that, why don't you say, hey, what's a reasonable solution here? I want to allocate. I want to use a concurrent hash table because I have multiple threads fighting over these things. What's a good answer? Not I made them big objects and they secretly locked under the hood and now I suck.
so so
Don't
so
bother
my
doing it that
my
way.
thought here is that I even though using a lock will create some contention potentially, right? My thought here is that if I can take less allocations by taking a lock, that is preferable to doing less locking and doing more allocations. That's my thought is like with the pointer. So if I store and cast pointers, right? I have to for my use case, I would have to allocate for each object. So I would have a separate allocation per object. And in my view, that is like less optimal because I'm viewing the cost of locking as actually being lower than the cost of allocation. Um,
What is the cost of allocation? This is a key question that many people blow. And
Well,
it in C++, it's different than Java. So there's a sweet spot here that one works for one language and not the other. What's the cost of allocation in C++?
I
that
think you're a
is
little
a
biased because you're so used to bump pointers, where an allocation always brings in new pages from memory.
I I
But
I hard go both ways, and I'm trying to get Ryan to say this to
okay.
recognize the difference.
So I actually didn't benchmark that, but but looking at the mutex example, let me see if I can write this real quick. But the mutex was only like what was it, like 4 nanoseconds, and it's like, hmm, this
Okay,
is,
so
or
you
sorry,
have
1.5
several
nanoseconds.
interesting things here in the high theory, large standard average deviation kind of cases. Mutexes that are never contended are actually useless. There's no point if it's never contended. If it's lightly contended and very lightly contended, then it's typically an L1 cache hit or an L2 cache hit, depending on your hardware level. If it's contended much beyond that, it rapidly exceeds all other things. In the case of an allocation, when you're allocating off of a free list, which is what malloc and free do, it's fairly cheap. It's some pointer math manipulation, bump pointers. You can go count nanos, but it'll be nanos. You go to a bump pointer allocator and you're hard guaranteed that the new object you get is not in your cache line. So it's a hard cache miss. And a large count of allocations will then have a large count of cache misses, and that will be all your cost. And I got benchmarks and classes I teach that demonstrate this very thing. It's very easy to witness it on easy common use cases. Okay, so now you come to the sweet spot. I have a thing where I'm going to allocate because I have a larger object, but I'm doing it in C and I'm kind of expecting to free that memory and reuse it over and over. So I'm allocating and allocating and freeing, which kind of conflicts with this notion I'm going to lock it and another thread's going to grab it because then it doesn't get free anytime soon. Unless I'm doing a producer consumer, it can happen. You could be there. Um,
Okay,
if
so here I
if
have
you're
some.
not, hang on. If you're hanging on to an object for a long time, then the cost of allocation just doesn't matter because
Can I?
it's amortized over a huge period of time. So that kind of a use case things. You send it into a hash table, somebody else is going to grab it. Is there contention on that table or not? That depends on the load factor. So maybe you could be fine. I could be
Can,
fine, and both statements could be true. You have an efficient implementation that allocates and doesn't lock very often. I have an implementation that allocates and never locks, and both are good in our different implementation strategies. But confusing the two is important. I mean, it's important to not confuse the two because things that are cheap for me are expensive for you, and vice versa.
can I share my screen real quick?
Just
Uh,
a second.
I have created a benchmark for the allocation as well.
Yeah.
Let's see here.
I guess to clarify with the allocator, so like we're using the lock as like a sort of like as our artificial bottleneck to make sure that the container we're using the lock as the artificial bottleneck to avoid the contention of the other bigger bottleneck or vice versa or something like that.
His thesis is that the lock is more expensive than an allocator. So, I mean, sorry, the other way around. That the allocator is more expensive than the lock. Since he's allocating already because the object's big, he might as well also lock because he has to put it in the hash table at some point anyhow. And then he was
So
back and forth over if they have small objects that go direct in the tables, a C++ thing that you do that Java has difficulty doing. So, okay, so when you run this benchmark, I need some information here. Is this single threaded? One
uh
core doing things.
yeah, this alloc this is a single threaded benchmark.
Okay,
Right, I guess
so
we might be screwed on the contention of like mutexes.
yeah, a serious flaw in this benchmark is it tells you single threaded performance, in which case you don't have to lock because you only run one thread. So run that with as many cores as you have, all in parallel, allocating independent streams. They're unrelated allocations, and see what you get for a cost on your allocator. Because you're an x86, you will rapidly run out of bandwidth. And commonly, not always, commonly, people have locks under the hood on their mallocs at some point, and you'll be banging up against that as well. So your cost of allocation will skyrocket, as you add more cores that are parallel consuming allocate. Like, why are you writing a non-blocking hash map? Why are you writing a hash table with locks in it? Because you're running concurrently. Why are you running concurrently? You got a bunch of work to do. Every thread's allocating. Okay, you want to time allocations? Time the rate of every thread allocating.
Right. So
That's
I also so in my like realistic use case though, okay, I have like 100 nodes with each node has a hash map and those have 16 shards. Like the number of shards is so high that I feel like most of the time that contention doesn't happen.
I said allocation. You said allocation, so I'm saying allocation.
Right.
What's the
Right.
cost of allocation
Pretty
when a
high, I
hundred
imagine.
cores? You say node. What do you mean by node? You mean a core on a CPU?
Yeah,
Oh, so I was talking about like my like basically I
Yeah,
have like 1,000 locks
yeah,
separately
yeah. You have a very widely
and
striped
16
locking set,
cores.
which it could be that you have very low contention because you've striped it so wide. That's fine. That doesn't answer the question of, what's the cost of allocation when 100 cores are trying to allocate?
It's a good question. I don't have a multi-threaded benchmark right now.
Well,
I
you
could
don't have,
create one, but
do
I
you
have
have
to
a
figure it out.
multi-threaded machine available to you? What's your laptop, whatever machine you're using, have?
Yeah, it has 16 cores, but I
Yeah,
still have to
those
implement
16
it.
cores will run you out of memory bandwidth in a hurry. And the cost to allocate, if
Not
you're
this
actually
one.
using the cores, will
No,
jump a lot.
this machine has like what is it like 400 gigabytes per second of memory bandwidth?
yeah. Whatever the memory bandwidth is, you have so much more compute than that.
Yes,
No,
yes.
not on the Max.
The
Maybe on the
Macs are
Oh
better.
x86.
no, yeah,
They're
Even
a
yeah.
lot
like
better.
Like
still
it
on the
really
max,
doesn't matter
yeah.
what the machine is. It's
Yeah,
really hard to
like
like not build a machine that way.
Yeah, you'll still run it out. Yeah, it's easy to run it out.
well, like because like I think this one is like how much M4 Max? I know it was like mm,
So, so you have a machine and you have a goal and a mindset in mind. Go optimize for it, and way to go. But I just wanted to clarify because you said on Discord, "Hey, you had to allocate here, and you don't." Non-blocking hash map does not need to allocate.
okay, so this is 546 gigabytes per second of
Yes.
memory bandwidth. So it's basically because they use unified memory. It's the same like memory they use for the GPU. So
Yeah,
it's like
yeah. We know what a Mac
basically
is.
yeah, GPU memory. So it's not as bad as an
Divide
x86 where
that
you have
by
like
16 cores. You get, I don't know, I can't do the math in my head, 10, 20 gigs per core. Have a core do a bump pointer allocation filled with zeros. That's
okay,
5 bin clock
maybe
cycles
in
on a
that
3 gigahertz
situation.
machine. You're burning triple, quadruple more bandwidth than you have available if you're just allocating. You will drown you'll run out of bandwidth really quick, even on a Mac.
And then if you're doing like multi-threaded things, you're going to be forcing other cores to be evicting.
Yeah.
So like you'll waste cache lines that like
Yeah.
you could have used longer because you have to evict them because other people use them.
Yeah. Yeah. This is right. This is where you start to get the costs involved. So if you have an interesting test case, go optimize for it on your Mac, but know that you're making a trade-off that isn't necessarily true for x86s and isn't necessarily true on the next benchmark or the next language.
Yeah, I don't know whether it would make a difference for x86. I know it's like a third, but I still I I I did this a
I missed the
similar.
beginning of the meeting. What is the symptom that's being observed?
The symptom for me was Ryan said, "Hey, if non-blocking hash map doesn't take a lock, it has to allocate." And I'm like, "No, it doesn't." So I went down the path of you don't need to allocate to do a non-blocking hash map. And then he was like, "But if I design a hash table this way, where I put things in it, then I have to allocate here or this." And then we're getting into general discussion about how you design concurrent hash tables and the trade-offs that come around with them.
I mean, it seems like there's kind of two separate things, right? There's the question of how do I design a non-blocking hash map on pointers, wherever they came from? And then there's the separate thing of, well, okay, if I have pointers, they have to live somewhere. And I think that's sort of where the assumption of, well, they have to be allocated, right, comes
Yeah.
from. But, it sounds like your point is basically, to make a non-blocking hash map is pretty much independent of that.
Yes.
One other point, if I can quickly make it here, as we're comparing locks to mallocs, depending on the malloc you're using, and I mean, pretty much this is universal for mallocs, Your malloc is probably also going to be locking. Like your malloc, assuming it's not purely thread local, which it seems like you're just using the standard, like whatever is associated with your C++ standard library, which on Mac OS is like a pretty decent malloc, but like it's not super, super fast.
I would assume they would switch to a concurrent malloc pretty quickly. I don't know.
I think there might be a thread local cache. I
There
am
I
also
are
think
aware that the
tulips
OS
CLE
definitely.
has one. I know that. Well, actually, it's like core local, so it's got like this weird thing with like obstruction freedom.
Okay.
Yeah, like if you get
for the Mac
context
one
switch to the middle of a
specifically.
malloc, it'll like it'll switch which like store it uses because it tries to make them like core local.
Right. Right. So he's doing something
Interesting.
to make
On
an effort, make it
all,
thread local,
all,
core
all
local.
I'm basically aware of is that the Mac malloc is like not awful, but there's definitely better ones out there. If you want to actually get like an accurate measure of how costly like malloc is in terms of like I care about performance, so I want my malloc to also be fast, I would probably try something like I don't know TC malloc or like my malloc, like the Microsoft malloc. Those, as far as I can tell, are pretty close to the you know fastest right now. And in practice, they have a lot better like behavior in terms of locking than I've seen some other mallocs do. I mean, like they have different approaches, but I think more on a like approach like perspective though. If you think about what a lock is actually doing versus what a malloc is actually doing, both of them are maybe going to do some sort of like load to something and maybe have a happy path, but then otherwise they're going to fall back to, some sort of contended memory access. Really, like the bottleneck for both an allocation and a lock is like pretty similar. So it doesn't really make a lot of sense from like first principles that like a lock would be preferable or faster than allocating. Like maybe that just means your allocator is not sophisticated enough, or maybe there's a tiny difference, but locks can also, fall apart pretty fast.
I'd also
So
argue that depending on like the access patterns you're going for, or I
yeah.
guess allocation patterns. So for instance, in my like linker and in a few other places where I use like non-blocking hash maps and hash sets, what I'll do is I'll have these thread local arenas, and then I will allocate to the top. And usually I'm like inserting the things. I'm like, oh, if I fail to put it in, then that means somebody else put it in, and like in which case I'll free mine really quickly. But like I'm bumping off the top and I'm explicitly doing so. So I'm not really contending on that like base layer of allocation. I'm contending on whatever comes above, but then that's handled by mimiamalloc, and then that's not contending until another allocation layer, which is a lot higher up.
In the Java implementations, every thread has a thread local allocation buffer, and there's no contention on that one. When that runs out, then there is contention when they go grab another TLAB buffer. It's the same kind of hierarchical of you
Yeah.
get a non-contended and a rare contended bump.
Yeah, like if you think of like, or I guess even more specifically, like if you have a lock and you want to lock it, that's always at minimum some sort of atomic operation. Like there's no real way around it. You need to do some sort of atomic, and like that can be a reasonably cheap hardware instruction, but like it's not going to be the cheapest hardware instruction. If you're in a malloc, like doing an atomic of any kind is like a nightmare scenario. Like if you want to make a fast malloc, like you want to keep the atomics outside of your fast path as much as possible. So like a fast malloc should be doing like broadly cheaper operations. Obviously, it's all still memory, so who knows? But
Let's assume that a fast malloc is available, or fast concurrent malloc is available, in which case the happy path bumps locally and the slow
yeah,
path probably locks.
which
Yeah,
is you just link mimimalloc these days, and that covers
right.
it for you.
Away from it.
Or
Yeah.
you can write your own. It's not that hard.
But
So
what I found in my little benchmark, and I mean, this was like the probably the best case scenario, which was that single threaded, was the lock taking, and this was my like okay, so standard mutex lock was like 4.2 nanoseconds. My fast mutex was 1.5 nanoseconds, and then the allocation with whatever macOS comes with was almost 10 nanoseconds. That was just one allocation for an int.
Well, yeah, but I think I would say don't necessarily trust whatever macOS comes with to be the fastest malloc available. Like I've known a couple projects that like specifically write their own malloc that, because it's such a throughput issue to use the standard one. Um, the other side of it is actually specifically on Mac, uncontended atomics are like extremely optimized on Mac hardware. So the fact that it's actually only like, I don't know, 10 cycles or something to do like the
yeah,
ostensibly fast, like uncontended atomic of your mutex is not surprising. That probably will fall off very rapidly as soon as there's any contention. Like Mac hardware is like super well optimized for specifically the happy case of I want to do some atomic little operation and no one else is trying to do it at the same time. Mostly to enable like ref
x86 these
counting.
days is as well.
It's pretty good. I think like Mac is like a different level to my understanding because they are so heavily optimized for ref counting. But x86 is also
They also have a
like
weak memory model, so that that especially helps.
yeah.
Are they
And
really?
Intel has to
But
basically treat every operation as if it is not only atomic but like well ordered. Like, oh, your stores have to be well ordered and all that
Yeah,
stuff. It's
no.
like you just
Yeah.
don't have to do that on Mac, or
Yeah.
like by default at least. I think the M1 has like fancy x86 memory model stuff, but yeah, that's for like emulation.
also yeah, like I
But
have
it's
seen
got
also like
barriers.
Intel's gotten a lot better recently.
There was a time Azul was the first person I know who could do Azul hardware. Was the first one would do CAS is hitting in your L1 cache. If no one else contended and you hit in your L1 cache, it was, or 2, 3 clocks. And then Haswell, something was like 5 or 6 years later, Intel finally could hit in their L2 on a CAS up from main memory, full cache
I
miss
mean, you need
overhead.
a lot of hardware for cache invalidation signaling if you do that.
You don't. That's the sadness. I guess you need it in conjunction with the rest of the x86 model. Because Azul was like El Cheapo cache hardware as well. It's really simple. It's in my L1 to start.
Right.
I'll read, write, and go back. It's still in my L1 when I wrote it. Oh, well, then it was atomic. Oh, it was not in my L1 when I went to go write it. Abort, fail. It was like
Right, but that
nothing at
means
all.
if
There's no cache
CPU
protocol.
B reads into its L1, it has to notify all of the other L1s to invalidate.
No, right, right. So the first CAS goes in, and it's not in my L1, or it is, but it's shared. Then he fails and says, "Oh, go make it, immutable and owned by me." Is if I'm writing it, and you failed the CAS, so you looped and you tried to CAS again. Oh, the second go around it worked, but that was because it wasn't in your L1. Now that it's hot in your L1, if you lock it and lock it again, which is people write Java code with synchronized keyword happen like all the time, I had tons of them. You lock it and lock and lock it and lock. It sits in your L1 and it's all happy path. But to get to the happy path, you had to take the cache miss overhead. So x86 would never get to the happy path until Haswell. And then in Haswell, you failed it to get it to your L2. Now that it's in your L2, oh, you get the happy L2 path. Just the timing. And since then, as far as I know, every chip's got the better version. Once it gets in your L1 or your L2, you're happy. This is the uncontended case. Of course, as soon as there's contention, then you lost it out of your whatever. You lost it out of your lowest private level cache and highest private level cache, and somebody else has it. And now you're paying cache ping pong, and it's all bad.
That's the snarky answer I was always given. My thing is slow because there's lots of contention. Okay, well, don't contend.
Yeah. 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 Why are
Which
you
on the one
contending?
hand is snark, and on the other hand, I found that in systems where you really start pushing on, okay, we have this giant critical section. What pre-work can I do to get out of the critical
Right.
section? What things can go
Yeah.
down? And
Yeah. You can
I've
usually do a
seen a
lot.
lot of systems
Yeah.
that started very highly contended that ended up being things like, oh, we just need to have a service that hands out serial numbers to everybody.
Yeah. For instance. Yeah.
And
Yeah.
that is super fast because it's not doing any work.
Yeah. Right.
And everything else is actually people filling orders and processing
Right.
things. And the only thing that was actually causing you to have locks was you needed to get a unique order number. And it's like, okay, well,
Right.
write
Non-blocking
unique
cache
order
command.
number and have that run in its own thread.
That started out as all these hash tables are contended and they're doing something stupid. And can we do something that's not stupid? Why are they doing this thing? And how little can be done here? And it eventually boils down to you need a CAS,
Do
a
you have
unique
advice if
serial
you're using
ID,
something like
a something.
non-blocking hash table of how to minimize your contention? Or is it way too
Yeah, because
application specific for there to be good rules of thumb?
threads were generally just doing independent work, and they would touch at these hash tables, usually caches, and it turned out that they mostly didn't need to be touching things. Like the set of times when they did a complicated, large multi-word atomic update was very rare that they actually needed to. That you had to think on it, and then you deciphered that, yeah, I don't actually do a giant multi-word atomic update that's visible to everyone else at the same time. Instead, I built a thing and then I installed it publicly And oh, it was done, and it was all atomic at that point. I built it atomically and then published it, and then my thread didn't have to wait on anybody. It's just us
No,
looking at random junky Java apps for us being Azul systems. Sorry, you're trying to sell slow CPU, high core count CPU, parallel Java apps. You look at a lot of junky Java apps and try to make them go parallel. So I don't know. You were from Twitter, where you had like load out the wazoo and 10,000 programmers adding new concurrent programs. Get
Yeah,
staying
I don't
behind the
think I
thing.
truly believed the Azul model until 2020.
Hmm.
And Twitter replaced a lot of its x86 with ARM systems. And it was like, okay, we replaced a 32 or 64 core machine with a thousands of ARM cores machine.
Oh, they had those. I remember those.
And the
Yeah.
cores were much slower, but the number of tweet views you could serve went up because it's actually pretty independent.
Yeah. If they're all running independently, yeah, yeah. They
And
were.
then I had another thought here for hash tables, right? So let's say I have a hash table, right? That it's like insert only. I'm not deleting things, right? Okay. So you could have two hash tables, and
I do
you
think
have,
never deleting
or
makes the allocation strategy easier. Bump
It
pointers are
does.
great at that.
It does.
but let's say like I have two hash tables. I have generation one, generation two. Okay. At one of them's read only, and I take a like a shared lock on that one, and then the other one is read write. And so if I want to look something up, I look in the first one. If it's not there, then I have to look in the second one. I take a lock on that. As I add things to the second one, there's also like a third hash table, essentially. Like we're copying things from the first hash table into the second one over time, like iteratively. And then at a certain point of time, you will have copied all the elements from the first hash table into the second hash table,
Uh,
and then you atomically
I,
replace the
I,
old hash table with the new
nope.
one, and then you create a new
Just,
empty one, and you
I
keep
just,
would
adding.
like to be the one to say that this is not like imagine this. Okay, so this system right here you've described. So now just don't have the lock on the insertion because you actually don't need it. It's actually pretty easy to remove it if you have like word sized like atomic keys and values. Now remove that part. That's the non-blocking hash map.
yeah. You're just describing painfully slowly non-blocking hash map. You
Okay, but I have
CAS
big objects.
to put a key in. You CAS to put a value in. So the value has to fit in a CAS, so a pointer. And then when you want to resize the table, you copy things from the old to the new lazily, slowly over time, but you CAS the old table slots to mark that this value has been moved to the new. Else you have a race condition where people can race to copy to the new and insert a change in the old at the same time. So you fix that with a CAS to say it's been moved to the new. And once
Yeah,
the
now it's
last
now some
object
read
moves to
only.
the new, you promote to the new table and you throw the old table away. And
And
this
those are
is
pointers into the object pool. Like,
yeah.
how do you deal with the fact that objects may be bigger than a pointer?
In the case where objects are bigger than what you can CAS, you need use a pointer. You need an atomic word to put the value in, an atomic update. So whatever size your atomic update is, that's the size of the thing you can put directly in the hash table.
I guess the confusing bit to me is like it feels like we're treating like void pointer to void pointer like hash maps here as a lot more or like we're treating allocations as a lot more expensive than like my experience with them has been. But maybe that's because I have like the easy version of the problem with a lot of like compilery things where I can just say, oh, I do keep allocating and I do just keep bumping up. But like if we're doing the immutable case where we just keep growing, then like we can do that. Oh, yeah, that's the other thing. With the non-blocking hash map, you can also like remove things. There's nothing really stopping you from doing so. So it doesn't even have to just be immutably growing.
Yeah.
Well, I guess my thought here is like I'm looking at this and I'm seeing like an allocation being 10 nanoseconds versus lock unlock is 1.5. So from my perspective, right? Okay, if contention doesn't happen, which I'm not saying that that's always a valid assumption, but based on my scenario where I have 1,000 separate tiny mutexes that are 8 bytes, most of the time that contention shouldn't happen, right?
Well, until you resize, for instance. Like if you're sharding, you're going to resize at some point, and it doesn't matter how much you like regardless
So
of whatever happens, if you resize, that like entire lane is going to be locked up. And so like
right, okay.
yeah,
So my thought here is like, okay, if the majority of the node, if the majority of the lookups are for elements that already exist, it will only be like new insertions that would get blocked on the like, because like the time period for like, yes, there would have to be like a shared exclusive lock to like switch over to the new generation table, right? But that shouldn't happen very often. Like the incremental rehashing would be read only from the old table, and like I'm not deleting the like pointers from the old table, right? I still have the memory allocations, but I'm not like deleting the pointers, like because I'm thinking like allocate once for the region of data for each object, right? And then there's like a bump pointer inside of that allocation region to like store multiple different objects in the same allocation that like the allocation belongs to the table, right? And then um the update would be like take an exclusive lock over the first table and then swap the two.
yeah, I guess what confuses me is like, okay, it sounds like you're building like half of the non-blocking hash map and then
Right.
making it block.
Just finish the job, get the other half.
Yeah.
I see.
I will also note that they're not that huge. Like I have one. Well, I have a public one actually. One sec. It's like in C.
Non-blocking hash map?
Yeah.
The entire hash map starts, for me, it starts as like a 2 or 3
Okay.
word object and an array with
Okay, so
slots,
let's
like 2
let
slots.
me rephrase the question. The reason I have used the like the blocking version is because I am not sure how to implement a non-blocking version where
I'm
I do
looking for the
less
slides.
allocations. Like I'm not sure how to do the non-blocking version with less allocations. So how would you do, assuming that I need to allocate memory somewhere to store the object that I'm putting into the table, right?
Yeah.
Um, how would you do this in a way that reduces the number of allocations so that the total number of allocations goes down? Because that's my objective, right? That's why I picked this.
Well,
Like,
what do
okay.
you mean by allocation? Because
Yeah,
that's like
exactly.
a blurry category. Because like for instance,
Yeah.
I was using the thread local arenas earlier. So like the amount of heap allocations or the amount of OS calls that I'm doing is significantly lower than the number of object like allocations that I'm doing. And the
all right.
object allocations are in the nanosecond range.
Right, so I guess like there is like sub allocation happening from my perspective. Like grabbing a chunk from the allocator costs a fair amount of time, right? Like, but if I
How
want
much
to
are we talking?
well, in my benchmark here is 10 nanoseconds, right? And that's in the case where there's no contention on the allocator locks. So there's obviously locks inside the allocator. Um,
Well.
I would
I mean,
recommend
like,
having a thread local cache.
I would say like if you're not if your allocator if you don't know if your allocator has a thread local cache or not, then you should probably make sure you're using an allocator that does.
Yeah.
And then once you do that, I would expect the contention to be extremely slight, even for a pretty large number of
right,
threads.
right,
Like,
right. I guess the thing that I'm thinking here though is like even if in the single threaded case, I don't think the situation can get any better. Like if there's
you
a
could use
thread
a better
local,
malloc for sure. I would expect the allocation time. You could probably cut that in half.
you
But
think a 5 nanosecond is reasonable for
I think
Allen?
maybe less. I mean, like a
Yeah,
fast
for an
path for a
arena,
malloc
the speed
is.
is like you're just bumping, so it's just an addition, which is like a third of a nanosecond, really.
No,
Yeah.
because
The
that's a
slow
third.
part is the
No, no, no,
rest of the
no, no.
initialization process, which is
Listen,
like,
it's your you do a fetch to the thread local storage base, you look up a free list pointer, you
Yeah.
do a store to adjust the free list pointer, and then you return the address you got from the free list. Like it's a load and a store and getting the TLS base, which is like pretty
So
cheap. And that's
yeah,
pretty
okay.
and your
close to
code
what your
doesn't
lock is
wait on
going
a
to do.
store. It just like lets it happen in like async or asynchronously, basically.
Yeah.
So it's
Yeah,
like,
yeah,
So
the fact that you end with a store is like
yeah,
useful.
well, I've checked this. So like doing an increment is like 0.27 nanoseconds, but that's only if it's non-atomic, right? So if your
Oh yeah,
thread
this is all
local is
well,
like,
non-atomic.
yeah.
Yeah.
The thread local store doesn't need to like it doesn't need
It,
atomics.
that's the point of
it
thread
do-
local. It
Yeah.
doesn't use
don't
A
don't
atomics.
you
Yeah.
typical
don't
malloc
you
will do a synchronous operation of some kind, like an
wait,
atomic
hang on,
allocation. For
hang on.
small objects, I would expect it to be like 1 in 1,000 allocations. Like you're not going to do much better than that.
I think it's, I don't know, maybe this is not the case, but I understood that thread locals were kind of required in atomic. So
No.
No.
Uh, There is a separate operation, which is sometimes not the most optimized, where you need to fetch the thread-local storage base.
Right.
On Mac, it should actually be pretty trivial because it's just a register. But on x86, it's like a segment register, and I don't know. I think that might be like slightly
No
slower.
segments.
It's not very
No
expensive,
segments.
but it is like an extra instruction.
So for
Yeah,
Java,
Windows has like a weird case where they do like a triple indirection or something. I think Linux generally does a double indirection. I don't know why Windows does a triple indirection. It's like a weird thing.
I think
Java
some of it is also
does a bump pointer on thread local allocation. Literally, you once per JITted section of code, you loaded the base of the pointer allocator and then you bump it. And if you run off the end, then you take the slow path. And the slow path, yeah, has locks.
Okay.
oh yeah. Like if you're
The
if you
chunk
fully
you
control the
got was
binary.
generally 4 megs or bigger. So you got a lot of objects out of that.
Okay, so it is a little
Java.
faster. I just did a benchmark. So I did an increment of the thread local. It's 1 whole nanosecond to do that. But
Uh,
that's less than I was expecting. So Mac does do something with theirs.
here's another angle that I think is worth considering. How do you know that 10 nanoseconds is too slow
Yeah.
for whatever you're doing?
Yeah.
Like do you know that this is the bottleneck? It sounds like we're at the stage of doing
Well,
pretty basic early
I'm
benchmarks.
I was just like, okay, if my lock unlock pair is 1.5 nanoseconds, right? 10 nanoseconds is larger. That's all I'm saying.
I think
It's like
it's
So
worth taking these sorts of things.
come back to the benchmark on contention. If you never see contention or only ever like contention, then you're making the right calls. If you're running 20 cores and they're all hammering in the same table and your contention shoots to the roof, you've got the wrong call. But what's your workload look like? Are you expecting to see that? You're running some big MySQL databasey thing, you might hit that contention case. You're running, I don't know, there are all kinds of stuff you could do. I'm parsing some giant log file looking for some random thing that might never have contention. I'm just going to burn through the IO as fast as it goes.
Here's another thing that might
Why
not
do
be
you,
covered in your benchmark.
what's your use case?
Well, and another thing, like if you're as you're benchmarking this in terms of doing these like lock operations, the alternative to allocation is that you actually store the values in line, right? And I mean, this was sort of the initial question, like how would you actually put together like a concurrent hash table that doesn't have to like separately allocate all these pointers? I would say probably if you're measuring a non-allocating version, putting aside that you could probably make some specialized allocator like a thread local bump allocator or something. I don't know. But otherwise, like I would say probably an important part of that is going to be shuffling all that memory around. Like that's, hard to avoid, right? Like unless you
No,
actually allocate your
hang on,
pointers.
hang on. So the design of the non-blocking hash table doesn't need pointers, but it can. Java typically does, but you could put structures that fit in a casable thing. It has to be casable, it has to be atomically updatable.
Oh yeah, yeah. I'm
You
just, I'm
pre-allocate the
assuming.
storage like an arena.
Yeah, yeah. I'm
There's a
just
one
assuming like,
allocator, one allocation to pre-allocate storage, and now the table doesn't allocate when you add an element or remove an element or change an element or whatever. There's no more
so
allocations other than one to make the table.
so
oh
so
yeah,
here's
but
my
well,
here's my question though. If I have a thread local allocator, right? How does it handle freeing without doing any atomic synchronization during the allocation phase?
Well, the point is that it doesn't
Usually,
free.
a thread local guy uses some sort of application level know when to free. So in the Java, of course, the
That part
JavaScript
makes
doesn't.
sense. But the earlier we were talking about a case where we're like growing the hash map and we're not really like removing entries. So why would we need to like free, except
Right.
to free in bulk?
Yeah.
Right, but
The
I'm
table.
talking. Okay, yeah, I'm thinking about like my alternatives are system memory or like implement my own allocator. And like from my perspective,
You grab one of several mallocs. Like he says, David
Yeah,
was saying me malloc. I know
me
DL
malloc is
malloc
my
from years
personal
ago would
favorite.
go parallel
like
under the hood.
the example of why like vector, for example, of C++ is more efficient than using the system memory, because with vector I'm not making because like even
Yeah.
if the allocation is super fast, right? Let's say that the allocation is that 0.27 nanoseconds of just an increment, right? In this case, I still like if I have an allocator that is malloc, it has to store metadata in something somewhere that is going to be preparing the memory for a later call to free. And for a like standard alloc, right? It's usually like a header that's at an offset relative to the
This is
start.
not
this is why we
not
go
so
to
much.
thread
I would
local
say
allocators. Arenas. By
Yeah.
any other name, an arena, a region.
Right, but malloc, does malloc use arenas? Like
So I would
So
say
mimiamalloc, for instance, is basically just a bunch of free lists on arenas.
right, so let's say it has free lists on arenas, but it still needs to know the size of the allocation when it's putting something into a free
Yeah.
list.
you can
So
usually
it
fetch that
needs
from the block that it's in, so you just round the pointer down. But it's actually there's a lot of, there's
right.
a
So
lot
now
of
There's a
you
lot of
tricks in
tricks to
these
shrink
usually
the
to avoid
overhead
them
yeah,
of
actually
okay,
being
things like
okay,
blocked.
okay.
allocation headers.
But now your allocation is not just an increment. Now your allocation contains a branch.
To be clear,
In
by the
my
way, if you do want to cut out those object headers because you're like, oh, I can cut them out because I know what the sizes of my objects are, you could do that. You could just make a pool.
that's what containers in C++ do. They do that for you, right? Because like
Well,
if I
no,
have
they do that
vector,
on top of the heap, though. Like,
yes they do,
Yeah.
but I'm saying like in some ways, if I create my own container allocator, that container allocator gets the memory from somewhere, which might be malloc or it might be memory map. But like
sure.
at some point, it's still doing that
There
thing. It's
is
like
an allocation, yes. Some slow path happened to get you some initial chunk of memory for any of these. Having obtained a chunk of memory that you want to treat thread locally, there are a bunch of strategies that devolve very cheaply to bump pointery like things. You're correct. If you're going to get rid of an object header and support a free, then you need to know the base of the object, for which a strategy is to align by powers of 2, for instance, and be a little sloppy on your object size, but in exchange, there's no object header, stuff like that.
so my argument is that the map should essentially be the one that is like maintaining that like pool. Like if the map itself contains a
That is a
pool, it
design,
can.
but I'm not going to claim that it should be that way.
Yeah, I think in
Certainly, in a
practice,
garbage
most of
collected
my
language, it should not be that way.
yeah, in practice, most of my allocations with like a non-blocking hash map and hash set, they do actually end up using allocations. They just like pull from like usually an arena.
Yeah.
But like even though I always do that, I don't actually like make it part of the hash map because there's nothing that really needs to tie it into the hash map.
I don't know. I like strong memory model semantic, like or strong ownership, like the way C++ does it, because it's very like a lot of people are like, oh, C++ has all these memory bugs, and I'm like, yeah, if you do all this manual pointer management, but if you just use containers and like container managed memory, like all of these memory bugs just don't happen.
You know,
Unless like
for me, the thing that makes the memory management bugs go away, especially like the allocation and freeing, is just like not like arenas really. It's like if I can just bulk up, if I can just group a bunch of lifetimes together, then I'm like significantly better off.
Yeah.
Like with the linker, I just say
Regions
like, oh,
cut a
it
lot of
grows
that
at some
out.
point as things get imported, and then at some point I'm done with everything, and I just throw it all away.
Yep.
oh yeah, that's great for one-shot algorithms, and
Yeah,
that is kind of what I'm doing here. Is and yeah, I could use an arena allocator in my particular use case because I'm actually not freeing any of that memory until like the compiler shuts down.
Right.
So
oh, okay. Yeah.
Compilers
Yeah. If you're doing
land
that, then definitely
squarely in
just
that
drop some
category, yes.
arenas on each thread, and then they'll eventually pull from like some heap or some like OS or whatever. But like for the thread local accesses, they're not going to do that, and you just keep growing it.
Yeah.
You can also do a fast freeing if you have like, for instance, like let's say you and somebody else both insert onto the table, and then you go, oh, the entry's already in the table. Then you can just like bump it back to undo that most recent allocation.
yeah, I would also want to have like a situation where I can like uh if I want to allocate some memory, right? I want to be able to free it later because I would potentially have the compiler running as like a daemon. So it would not be a situation where I would never free memory. It would just be like I would free it all at once when I'm done compiling this thing, and then I want to like compile something else next.
Yeah.
Yeah. Compilers are very phase batch oriented, and
Yeah.
between batches, it's very natural that you can just reclaim
Uh,
everything.
There was a famous story of that when they first decided to add Git features to VS Code. And they linked in Git and they noticed that they were leaking memory and it would just leak and leak and leak and leak and leak. And then Visual Studio would crash. And they would leak and leak and leak and leak and Visual Studio would crash. So they're going to see like, what is this leak that's in Git? Git's been used for years and years and years. How can it have a memory leak in it? And they call Linus, and Linus is like, Git never frees memory. It's never running a command that lasts for more than 2 seconds. I allocate, I do my work, and then the process ends.
Yeah, it's
You're
running
the one
like
who
one
decided to
command at a
link my
time.
thing into your long living Visual Studio that people
Yeah.
leave open for weeks at a time.
Yeah, I've seen a lot of GNU tools use that approach. I don't like writing code like that because like it creates the situation where your code is not reusable. But yeah, it does make sense. Like in my mind, that should just be an allocator that you pass to a template and be like, hey, this allocator never frees anything, but that's like application specific and the algorithm should
Right.
still do it
So
free, even if it's a
that's
no
how
op.
you fix it is you stick the whole thing in an arena and you trash the arena after you do some get work rather than just leaving the memory around
Nope.
forever.
The bonus black cat Lisa went running by the window. Sorry.
You have a new cat who's adopting your family?
Yeah, new cat. Yes, I think he adopts several. Also, there was a bunny rabbit out my window not half an hour ago, and I'm wondering if the cat was like looking for a little bonus protein.
Yeah, I need to do some more benchmarks here and like figure out, but like it's so far it seems to me like
Yeah.
okay, maybe a concurrent hash map could be a solution. It just seems like I don't know if I'm actually going to gain that much if I'm spending more time in the allocator, but we'll see.
One of the things, or the way I like to think about it, is that you really can't beat a good allocator implementation at its own game. Like if you're doing something that is morally equivalent to malloc, then you might as well just use an allocator that's optimized for malloc. The way you do better than malloc is by solving simpler problems than malloc is solving. And so if you can say like, well, for my application, it's perfectly fine if this is only ever thread local, or if you say, oh, well, I don't actually care about freeing individual objects ever, I just, I can free things all at once. Then those are, simplifying assumptions and you can change your approach. But if you want, a big slab of unique pointers that, manage their own lifetime and have all this like RAI stuff that you care about, um, then like I would say probably just start with a malloc and see if it really becomes the bottleneck because, those sorts of things really do value being able to free individual objects and have that work across different threads and things like that. So,
So the sort of the problem that I've noticed that where you can gain a measurable speed up over malloc is like if I have an object and I know the size exactly all the time, this is where malloc
oh
like
yeah, that's also,
it has extra conditions it does on the free and alloc to like pick from one
As
heap
soon, yeah,
or
as
the
soon as you
I
other.
get a
mean,
fixed size,
you
free
should,
list.
I mean, you should try a couple things. Like, it's usually not very expensive. Like, and actually, often in the fast path, it can avoid a branch, or like you'll have a branch to the slow case, but that's basically free because you don't often allocate things bigger than like, I don't know, tens of kilobytes.
I mean,
Hopefully.
there's no slow path and fast path if you have no branches, man.
So there is a branch.
There's a maybe
Like,
predicted branch, but
if you have a typical allocator fast path, there is some logic to like figure out what size you are. But unless you're like a big allocation, that's usually what the branch is. Otherwise, you're just taking some size, computing some, index from it, and then just looking that up in some array. So it's just part of your load. And you do a little bit of like integer arithmetic, and that is a speed up by saving that. If you have a known homogeneous like slab of
right,
objects,
right. We still have to branch to check if the input size is larger than some threshold, right? That's a
oh yeah,
branch.
but that's cheap
Yeah.
because that's like that should be pretty well predicted unless you're doing like a million allocations that are all like 100 kilobytes or something. Like unless you're exceeding the size of
But
a page,
You're
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 almost
getting
never
into
going to take that
the
branch.
realm of highly specialized allocators in
there is something to be said for are you actually outcompeting the allocator? I know one story where I was working on this large Java app, and the performance team comes in to figure out if they can reduce the memory. And there's just 1,000 places with different little resource pools freaking sprinkled all over the app. And the senior engineer comes in and says, okay, I know that this is going to make things worse in the short term, but I need to be able to see where the allocations are so I can see where the pain points are so we can work on reducing the amount of garbage we're making. So the first thing I'm going to do is just remove all of these little resource pools and just let the JVM allocate the objects and free the objects and see what's happening.
and how did that pan out?
It got 1% faster. It
Okay.
turned out there were a bunch of these that were useful and there were a bunch of these that were wasteful, and they were roughly netting out to no value.
Oh, interesting. Uh-huh. So vast simplification, and we didn't change anything except we got a much simpler to understand app.
Right. And at that point, the tools could show us where the
Right.
allocators were.
Yes.
And he ended up putting back in two of the 978 resource pools that he found in the application.
900? Really? Are you serious? 900?
Yeah, there were 900 little vector, I need this array
Oh
of
my
objects
God.
as I'm looping through
Oh my
things.
God.
And we ended up
Wow.
getting about a 40% speed up from putting back the
Yeah.
two that were
The
actually
two
helpful.
that did something useful.
But we
Yeah.
couldn't see where we
Wow.
needed them till we removed all the others.
So the
And it was just a
others,
moment that gave me a lot of faith in Java's GC system that I was like, oh, this is actually
It works pretty
outperforming the
good.
resource
You can get to a
pools
bad spot with it for sure, but it
because the
mostly
resource
works
pools
pretty
were just
well.
old and the shape of the load had changed. It's not like the person who put them in wasn't measuring before they put them in.
Oh, I've seen that happen.
It's just that the load changes over
Yeah,
time, and
okay.
your resource pool tends to be a lot more fragile than what the JVM is figuring out by
Ah,
counting things.
yeah, right. Okay. Yeah, I guess
But
I've been
it,
there.
it was definitely a moment that impressed on me the start by seeing if the JVM can solve your problem for you, and then worry about your allocation strategy.
Right. The moral equivalent when you
Applies less to C++ than it does to JVM because
the
allocations are
moral
more expensive
equivalent
in
is
C++.
to back away from the fancy things and get simple again, and then remeasure. Remove the fancy algorithm that was supposed to make you faster, and get simple. Measure and decide if you
Um,
you really need it.
okay, I've got
Also,
a, I've,
that you have to think about things that are growing exponentially.
Yeah.
If you're in a company
Yeah.
where your load is
Hmm.
14 times what it was 4 years ago, basically anything you measured 4 years ago is probably wrong.
Probably wrong. Yeah, that's a good point. I was
it,
thinking that the I've seen a number of allocators that were essentially variations of linked list versions of finding a hole in a section that worked great in the small, and in the large they went n squared.
so it, if you guys are still into synchronization as a topic, I actually have concocted a new synchronization primitive. Um, I don't know if you guys want to, if we want to go back to compilers or
Well, I don't care.
I
okay.
had one topic I wanted to ask about.
Well, fire away then, because I was going to bring
It's
up I have slides for non-blocking hash map and how it works.
probably more of an ecstasy question than, and we
Yeah,
don't have the
understanding, right?
person for that, but you worked on it.
Yeah.
Um, how did you handle doing capabilities? Like the core idea there was we have all these worlds and the worlds are separated and you can only do stuff if you have the capability to do a thing.
Hmm.
Was that just do the pointers exist? Was there something
Yeah.
more clever about how the capability system worked? Like, how do you do secure capabilities and get the compiler to enforce that and bytecode checker to enforce that? And
So the language said there's no reflection, or the reflection is only the things you could have done anyhow. Um, and then you had to be passed in a pointer or capability to go do something like print to the console or write a file, read a file. And you could be passed in capabilities that were sections of file systems and things like that. If I wanted to take some random garbage I got over the interwebs and a URL, whatever the hell, and then go extract something out of there, there was no path to get from there to go run an eval on anything kind of thing, because there was no path to that eval without first getting told I can go eval random shit. So if you didn't hand the parser guy an eval pointer, essentially,
so it basically all came down to the fact that you can't manufacture a pointer. I
yeah,
can't cast it into a pointer.
yeah, right. So it was going to. It might. I think they're still planning to run it on a JVM, but the ecstasy bytecodes, if you will have more constraints over what they do. There's also a constraint on denial of service. So total CPU consumed, total memory consumed, total this and that consumed, that has to be also factored in. So you're not allowed to allocate until the JVM dies, for instance.
Yeah, I've been seeing some interesting problems lately where people want to give a LLM access to run arbitrary Turing complete
Yeah,
basic math things. It should
yeah,
be able to ask what the length of a string is. It should be able to loop over a set of numbers.
right.
But you kind of don't want to give it the ability to read your entire hard drive and encrypt it to a public key that it then tells somebody else what the key
Yeah,
is.
you want to run it in a sandbox. Yeah, exactly. It's the same
Um,
things I got random crap over the internet that somebody says, run this code. Here's some JavaScript, run it, please. You put it in a sandbox.
yeah.
Now, is your
And I've been
sandbox have
seeing
holes in
these
it? Damn on
patterns that
you.
are like, we're gonna get the LLM to write some Python that will be run in Docker with a bunch of the Docker things turned off.
Right.
And
Somewhere
I'm
there's a
like,
sandbox.
no, what we need is just a REPL that has no bindings to anything.
Yeah, yeah.
And I was wondering what people's advice was for how you would go about getting a relatively easy REPL with no bindings to anything.
Kind of what Ecstasy's doing.
Right, that's what made me think of
Yeah,
Ecstasy and Ecstasy's capability systems.
yeah.
WebAssembly too.
I heard one person who was like, "Oh, we should link Lua JIT and just let it write Lua code that's not connected to anything, because if you don't
Not
inject anything, it
clear of the
can't."
sandboxiness of Lua code. But Matt was saying something.
Well, WebAssembly is also doing that with the capabilities that you can
Right.
have nothing by default. And there's a lot of custom sandboxing solution. Like there's this agent FS, which is basically a file system that is sandbox. It pretends to be a file system so that you can unleash agents on this and they can do what they want. That is gonna be remained inside the sandbox. I mean, it's pretty much standard computing, right? We always wanted something like capabilities. Now agents are just new applications of that.
Yeah. Yeah.
It's an interesting UI question because you definitely want to have. I mean, the browser's been doing a little bit of this for a long time, where the JavaScript says, "I would like to turn on the mic and camera," and the browser pops up and says, "Hey,
Yeah.
this website would like the mic and camera. Would you like it to be able to take pictures of you or not?"
Yeah. Yeah. And that's Ecstasy does is that kind of thing too. You could go ask for permissions and then get a container, get a pointer to or whatever that says mic and camera, or it says root of the hard drive with, admin access to rewrite your password file or whatever.
Yeah. I think some of the things are going to end up being very Rube Goldberg. It's
They are right now.
there's an
That phone
LLM
comes
running
up
a
and
bot
says,
somewhere and it needs access to do a thing.
yeah,
So it sends a Slack message to the developer that owns that thing that says, "Hi, I'm trying to do this. Okay, cancel." You're like,
yeah, exactly. I was gonna say my phone comes up all the time and says, I need permission to read, write, and edit your photos. And I'm Google Maps. I'm like, why does Google Maps need to edit my photos? What the fuck is that about? And if I say no, what stupid capability is lost because Google Maps is just going to say, I'm going to punish you because you won't let me edit your photos? I don't know.
so I do actually know that one.
Oh, you do?
So if you are at stores, it wants you to upload photos of the stores. The most common example of this that I've done is I tend to take pictures of the hours if there's ever something that's on Google Maps and I can't tell what the store hours are.
Oh, I
I was like,
see.
great, I'm going to upload a photo of the store. Here's the plaque with the hours.
Hours.
And
Yeah.
it will say, "Hey,
Why
I'd
did-
like to help you out in your photo picker by sorting your photos by the geographic distance between the geolocation on the photo and where you are right now,
So I'll
because
just look at
almost
all of
certainly the
your
photo you want to
photos
upload
and
is
upload them
that one."
to the cloud and hand them to an LLM. Please alpha sort these.
So if you don't allow maps to see your photos, then instead it opens the file picker and you have to find the picture you just took, which is the next one in the camera roll
Let's say it's
because
the
you
next one in
literally
the
took it
camera.
1 second ago, as
Yeah.
opposed to letting it sort them by geographic location. You have to go
Okay,
through them
fine.
sorted by time.
So no harm, no foul. Just say no, and you'll
Why
get a
should I
better
give you
answer.
access to all of my photos?
I,
You
I
can
was
sort them
watching
by
Intelligent
geographic distance to where I am right now. Like,
pick up AI things on his search capabilities. I've whined about this before, and he's way worse than grep. He's slower than grep, and he's stupider than grep. It's just unreal. He pops up, and I want to say, I want the node class. Well, I'm writing a compiler with nodes. I have 57 nodes. Also, as soon as I go outside of my application, every Google Com, Base, Apache Commons, blah, 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 has a billion node things. So I type node. I want node.java in my project. There's only can be one. And that will not be on any of my pick choices. There'll be hundreds of unrelated things that I've never loaded in my life. I've never seen this jar file that got imported by somebody. It's not my project. He went to some Gradle base, said, I can hand you, no, fucking get my thing. And then if I start typing more letters involved somewhere, he won't go for like constant node where I say con or constant or whatever. He will intersperse unrelated typings. Like I have the perfect spelling. I spelt the thing directly. And he'll add extra letters and say, I found this other class. If I throw random letters in, I can hit these other classes. But the one that you've perfectly spelled, that's in your project, that's in your directory that you're currently been editing seconds ago, I'm not going to give that one to you. It's just like, holy crap, guy. Fucking grep.
That was one of my favorite
Okay, done.
moments.
Line off.
If you look at the thought process of LLMs as they're working stuff out before they give it to you, and every once in a while you see these things that are hilarious, where I asked Gemini's model to find a thing that was in Drive. And it like does 3 or 4 different searches. And it eventually finds a document I'm looking for on its 4th attempt of trying to word this search. And then it reads the document. And then in its little thought process, it's writing out, wait a second, the exact phrase that was in my search, that was the first search, is in the document. Why didn't Google Docs search find my document with this exact string match in it? And I was just like, that's right, Gemini, you have discovered that Google Docs search does not always find perfect string matches because of the way it does stemming.
Confused by the other AI. we're rapidly
It broke me.
coming
I
full
laughed so
circle
hard the
here.
first time I saw Gemini complaining about Google Drive search, and I was just like, that's...
Somebody is paying the electrical bill to fund both idiots. And we'd all be better off if you just saved the power bill and killed them both. Wow.
Anthropic did that. The Anthropic Claude Code tool. They tried several different strategies of how to index all of the code that was in the folder so that it could find the things that it was looking for and give you information what's going on. And it turned out of all the strategies they tried, the one that worked best was let it call grep. It turns out most repos aren't that big, and grep is fast on modern hardware.
Grep is fucking fast. That's good.
I actually have a story related to this. I did this interview with a company and I had like implemented this like multi-threaded find, and they were like, oh, that's probably slower than just doing it in a single thread, right? And they were like, it'll just bottleneck on IO. This is pointless. So I made a like a complete like non-demo like actual application that you could run. And it was I benchmarked it against GNU Find, and it was like 27 times faster. Like it was more faster than the number of cores because of the way that NVMe queuing works.
Then what? Google Find?
GNU Find, GNU.
Oh, new Find.
GNU.
New Find.
Yeah, the free software.
Yeah, there were a few attempts at parallel grep that have been interesting.
Yeah, so like NVMe queuing these days is very important because I think I figured out why they thought it would be slow. I found out that Windows didn't do NVMe queuing because they were pretending that NVMe drives were SATA drives in their driver, and there was just like a wrapper around their SATA driver. So all of your parallel requests were getting queued up as a request to a fake SATA drive, and then that fake SATA drive implemented the actual NVMe interface under the hood on Windows. So if you were on Windows, you would never see any of the like speed up that I was seeing for like, okay, I'm thinking there's parallel IO queues, right?
Does this make it
Windows
into
had
the
none of it.
docs? Yes, it did. Okay, thank you. All right. Is there any chance we can roll this back to compilers, or we should declare ourselves done?
I do have one sync topic if you want.
Yeah.
So I have kind of a new structure. I wasn't really able to find anything that quite matched what I've done here, so I'm not sure if there's an existing name for this, but basically I'm calling it a relay.
There's always a paper in the 60s with a different name.
Yeah, I'm sure there is. I asked AI if they could find it, and they weren't able to find anything that quite matched what I was doing. There was some things that were kind of close. But so basically, let's say I have like a mutex, right? And I want this mutex to have an additional property, which is that it can take a baton object, right? And so think of this as like a queue, but like or a channel, right? But the channel can also be locked and unlocked. And so like I can do the operations that I have is like try lock else deposit or try lock, and then I could also do like deposit, and then I can do like try collect one else unlock and try collect one and unlock.
And whenever you're done, you hand the token to the next person.
Yeah.
Essentially, but there could be more
I think
than
I've
one.
mostly heard this under the name token ring as opposed to
Yeah,
baton.
it's
but-
not quite the same as the token ring because like that token is like there's so this the relay could store like more than one baton, and like a token ring is like I've got a token and then I go do something. It's kind of more like a semaphore to my understanding, but this one is more like, okay, I have a continuation, right? So like let's say I have a mutex, but I'm not a thread. I'm a coroutine, right? And so I have a continuation, right? And so I can say try lock else deposit, and then that baton can be my continuation handler.
Deposit? What does it mean queue? Does it mean goes
It's,
to the queue somewhere?
yeah, essentially there's a queue or a stack.
So the
So
queue
pull it off the top of the queue, check all the dependencies. If it's not ready, throw it on the back of the queue.
is the queue shared between the because it's starting to sound like the actor model, but each actor has its own queue or message box. So it's a little bit like that.
Yeah, a little bit, but it's like so like think of like let's say I want to lock a mutex, right? And then if I instead of blocking on the mutex, I basically say here is my resume function. And so it's always like non-blocking. I can't block. If I fail to acquire the lock, I just post my resume function into the lock. And then I stop executing. And then when someone goes and unlocks it, that unlocker goes and says, okay, unlock and collect. And
That sounds that sounds the semantics of a message. And so it's kind of when it's turn, so it will try to lock if it's the
Sounding more and
yeah.
more like Doug Lee's fork join. At the join point, there's a winner and a loser. First sprint in, the thing's not ready, so he has a continuation of the project, but he can't continue because the other half's not there. So that thread goes away and hits the work queue, does something else. But the next guy in finishes, and then he picks up the continuation.
Yeah, each thread has its own queue in that. Yeah.
So it like instead of associating work, like let's say I have some work that needs to go and lock the mutex, or let's call it a cotex because it's not really a mutex. It's coroutine mutex, cotex, and it's going to
Yeah,
it's gonna
It's
await
still mutually excluding a bunch of workers, no?
yeah, it is.
kind of. Yeah, okay. We'll call it a mutex then. So I want to lock it, but instead of blocking my thread in my executor, I'm just saying here's the continuation that needs to run when this is unlocked,
Here's
and then
the work.
the executor that unlocks it goes, okay, I've unlocked this, and now I have received a schedulable unit of work that I need to push onto my stack, and then execute later.
Yeah.
And
this is everything old is new again or something. This has been around the block a few times. And that guy says it's very similar to fork join frameworks.
I mean that's basically what this is for. Is the
Okay.
same.
That sounds like a synchronous work. Yeah. So
yeah.
I would account that for a future with a synchronous resume, and when the future is done, meaning that the log, you can get the log, you execute what was supposed to go.
Right.
Yeah.
So that's what this is for. It's for asynchronous coroutine scheduling, and
what fork joins for,
yeah. I wasn't actually able to find any structure that did this. Believe it or not, I looked. I could find things that were quite similar, but not quite good enough to do what I wanted. Or there were structures that had like multiple mutex and condition variable, right? It wasn't really like one one unit.
There's
I
a
wonder if
lots and lots
Dougley
of
has a good
flavors
talk
of
on
this.
YouTube about his fork join library.
Which one?
Doug Lee has a nice fork join library with a nice discussion on how it works and why it's efficient. It's another one of these things where he spends a lot of effort to make sure that the happy fast path doesn't do any locking.
So do they have like mutexes in it? Like that's the problem I was trying to solve, which was that you could have coroutine, like standard mutex can't be used with coroutines because like they can switch threads, right? So I wanted a something like a mutex that could be used with coroutines. That was basically all I
So
wanted.
he basically tries hard to not have any locking going on because he's coroutines. So instead of a mutex, if a thread arrives at a join point and needs to, it's a fork and a join fork. His join point, only half the work's done. He sets in his work. That's the marker for the continuation of what has to happen when the other half eventually gets there. And then that thread just lets go. So it's not a lock, but he cases in, I'm done. Here's the work I did. And the other half is somebody else is doing, and we can't do the join yet. And then that thread is free, or that coroutine is free and goes back to the generalized coroutine worker pool to do something else. The guy who second man in,
Yeah, it was some kind of double-ended thing.
yeah,
Whenever you put work on, you put it in your thread local, and you always
yeah.
you always pop your thread
Okay, the
local, but they
efficiency
always
hack
steal
is
from the back,
there's a
and
couple of efficiency hacks, and one of them is
the queue is weird.
I split the
Yeah.
queue in half. I take the large pile of work and I cut it in half, and I put the one half in the queue that might be facing to other threads. It has to have some kind of locking strategy, and I take my personal half and say, oh, it's still too big, and I cut it in half, and I cut it in half, and I cut it in half, cut it in half. So the queue that shows up for the other guy, if I pull from one end and there's a sufficiently large gap, I know that I can't compete with anybody else, so I can, without locking, grab and add work locally. But if somebody grabs from the other end, they have to do a CASI thing. But then when they grab something, they grab a huge ton of work because it's all powers of two going down. So they only grab rarely because what they grabbed keeps them busy for a long time.
So my angle here was I wanted something that could be used to convert existing code that uses mutexes into something that I can throw into a coroutine.
Oh, that's tough.
That's why I kind of designed this
Yeah.
structure. It was
Azul
not it was
certainly
not
attempted to get existing locking code to run more efficiently, and there's all kind of issues that show up. Fine.
yeah. So if you fork join, yeah, you don't have to do any of this, but my thought was, okay, let's assume that I have code that already exists that uses mutexes. How do I make that able to run with a coroutine scheduler?
Yeah, that's tough.
And
Um,
that's what the structure does.
well, I'd love to
Half
see it working
half
on
does.
any sort of general case, like specialized things people do all the time. That was one of my great understandings of watching people attempt software transactional memory things. Was that the software transactional memory generalized toolkit and the application were constantly being mutated next to each other over and over time to get rid of various bottlenecks and choke points and whatever until they blended into a single seamless thing, and it couldn't be considered a generic software transactional memory locking scheme, and it couldn't be considered a generic parallel app anymore. The two had blended, and that had happened. I interviewed a bunch of people, and I saw three large efforts where people spent tens of millions of dollars and tens of programmers over years, and they all ended up in that same zone. And no single, this is software transactional memory solution actually worked. And the Azul hardware transactional memory had the same kind of problem to make it go well. The application had to be modified. Um, so you ended up with, you modify the app to the HTML that you had in front of you. But in the end, both the app and the parallel execution strategy were heavily modified to fit into each other. And then it wasn't
Consistency
a
is hard.
generic, general purpose parallel execution strategy anymore. It was an application specific hack, which worked great for that app. Yep. Oh, Matt says TSX. This is their. I thought their hardware thing was out and did a couple cache lines, and it's actually going to get turned on. This says Linux. Why is it not loading? I'm trying to look. Is it going to actually? Because it says Facebook, which I've disabled.
It's big,
When I
right?
enable
It
this thing.
updates the biggest thing you can atomically update from like 64 bits to something like 64K?
64K. I thought it was a small, modest extra cache off to the side for this atomic updates, but it wasn't going to be not 64K. Really?
I think it was
Interesting.
64 kilobit.
64 kilobit or byte?
I think it was bit, but I'm not positive.
Why? Why?
Because the nomenclature they already had was 32-bit CAS and 64-bit CAS.
Oh God. Fine. I mean, okay, maybe.
It's just a big register.
Just a big fat happy register. Who knows? Maybe.
It's just a very big register that can be CASed.
Right. Yes. Yes. No. I'm kind of
Which on
bummed.
the one hand is like, yeah, 64K bits is a very wide register. And on the other hand,
Yep.
what problem does it actually solve that allocating 64K and then having a pointer that atomically swaps didn't solve?
Right. And then pointer swap, which is what the solution people were using for years. So I had a cool hack that I did a paper on that I'm bummed didn't get more airtime. You've heard this one, Aaron. This is the I want a bit one, which is the tell me if any cache line gets evicted. So I'm going to attempt an atomic update of a large count of things. And I'm going to read a bunch of things and write a bunch of things and declare this whole set of reads and writes are atomic. So I read a bunch and I want to write a bunch, except the writes all get stalled into the store buffer. And then I check my atomic bit. And if any of those cache lines were not in my cache from beginning to end, it wasn't atomic. And I throw away all those stores and I go reloop because I've touched them all. So they're all in my cache now. And I go again. And if on the second pass it works, it was atomic because no other core witnessed any of the writes into my cache.
So how big do you want that thing to be? The size of your L1
Well, you
cache?
need one bit that tracks the entire cache, and it's the size of your non-shared cache. So if you have an private L2, L1, L2 would be the size of your L2. You need a bit that
And if
gets
literally
set and
anything
read
got
by
evicted
jump.
from your L2, you failed.
Yeah, if it didn't stay in your
Even
L2.
if it was totally irrelevant to your transaction.
Yeah, that's correct. The point being here is that if you're doing them back to back, the first one's going to miss because you're big. You said it was a big transaction. It was 64 kilobits, whatever. It was a big. You missed something. Okay, the second one whips through at the speed of your L1 or your L2 cache. It's really fast. Likely, it doesn't miss anything at all. So at the end, you check your one bit. The bit says, yeah, no one else saw these lines. Atomically flip them, and now they're visible in your cache as, they were exclusive. Now they're exclusive modified in your cache. And the next time somebody does an evict out of you,
How much do you think that simplifies volatile?
The goal was to say I have a large atomic region that doesn't require a CAS and back off. It puts the spin loop into the algorithm, the same as the spin loop you have on CAS, basically, except has a larger space than one CAS. All right, but it didn't get any airtime. The Zool solution was somewhat more complicated, but didn't help anyhow. It was still as big as your L1, and unless you wrote algorithms for it, you typically failed because you had shared mutable state that didn't, in the hash tables of the era, there was the modified counter, which meant that if you modified a table, you had a shared mutable counter, and the other guy modifying the table, even if they're modifying unrelated pieces of the table, they all agree to modify the same word, so you failed a hardware transaction memory there. And if you
I feel like
yanked
there's
the
plenty
mod
of stuff
counter,
that Turing in church would have told you was equivalent, but
yeah, fine.
people can think in queues and channels way better than they seem to be able to think in lux.
Yeah, that's probably true.
I've seen people with very little distributed systems experience write Go code and essentially get it right with channels on their first try.
Erlang is all channels. Maybe.
And I feel like it takes a long time to get lux right.
Yeah. And that
I
was the
mean,
job
even
experience.
someone who's got a fair bit of experience doing distributed things, I think would have a hard time sitting down and writing a non-blocking hash map without writing some bug that they had to come back later and be like, oh yeah, I missed a corner
Well, I
case
didn't get
because I didn't
non-blocking
actually
hash map right the first go round.
like. My guess is you actually sat there and drew out state machines to get that right.
Yes, I did.
Did that
And then
involve
and then
pencil
I
and paper
simplified
and
it
state
after a
machine?
while. That was fun. Sorry.
Like I don't know. I feel like human brains just seem to do better with channels.
I'm not going to disagree. I'm
Erlang
not
has
certain
been the
how Java
language that
ended
I've
up in
kind of wanted
box.
to like for a long time.
Sorry?
Erlang is the language that I've wanted to like. The more I learn about it and the more I understand the model, I keep thinking this seems like a better way to write software.
Right.
Except every time I've actually sat down to write something in Erlang, it's like, I don't know, Python just feels easier to write code in than Erlang, and I
Well,
can't
Erlang, I
quite
think, has
tell you
pretty got the history
why.
for syntax. This would be like Go would be the modern equivalent, right? I mean, I'm guessing here, but it seems like Go is the modernized Erlang, if you will. Maybe there's a
Except that
better
Go
analogy.
very much sees its scope as a single machine.
Oh, really?
Go wants to run 1,000 threads, but it kind of wants to run 1,000 threads on one box.
Interesting.
And if you want to have two boxes, then you run 1,000 threads on box one and 1,000 threads on box two and open HTTP connections
They
between
don't
them.
talk. Yeah, right. I mean, H2O
Which
said
again is
you
fine,
lost it.
whereas Erlang always kind of wanted to live in the world
Yep.
of I stood up 1,000 machines and I gave you one REPL and you were able to program all 1,000 machines from your one REPL.
Yep. Right. Right. I
And
mean,
you just asked your question and you're like, hey, LS, tell me all the machines that are currently connected. Great. Spawn this thread. Call this function on that machine. Great. Done.
would you name it on the target machine, or you just throw out something to do and the management would pass the work around it?
Most of the systems I've seen, the scheduler that says which machine things go to is a library in user space. It's not part of the Erlang VM.
Okay.
I
So the
mean, it's
H2O
standard
solution
library,
there was to
but it
say,
is a library. It's not actually part of the language.
right, right, right. So if I look at H2O as a distributed parallel computation engine, but it has a big data store, the default answer was the thread moved to the data. So we asked the question, what data sets are you looking at? Those have a place, and we took you there, including the distributed version of the same. But you could say, go here and run, and
Yeah, there was
outside of
some
the
big
H2O
shared
model.
hash table thing that you could say, launch
Yep.
this function at wherever this key is.
The default was launch this function wherever this key is, but you could certainly say, go to this thread, go to this machine and launch. And in fact, the guy who says, launch this thread where this machine was starts with, what machine? Go to that machine and launch, right? So you could just say, go to that machine and launch. That was okay.
Yeah, the thing I wonder a lot when you talk about H2O that I just don't know is how different would it have been if long running persistent jobs was also one of the goals? It
I don't
seemed
know.
like the goal of Erlang was
Right,
I'm going to turn on this phone switch and it's
right,
going to run for 30 years and I'm going
right,
to keep changing pieces of the code over the course of those 30 years, but I'm never going to turn it off.
right. I get that.
The goal of H2O was I'm going to write my program and I'm going to start my job and I'm going to get my answer and then I'm going to shut down.
And they're going to shut it down. Yeah, yeah. It wasn't quite that way. People, the load a large data set took interesting time because large data set. So once the data set was loaded, you left the cluster up and you hacked on it. So you had a REPL and you sat there and you did some, type with the REPL and you ran out in the cluster and came back, got an answer, and you typed in your REPL. And you could have multiple people use the same cluster. But we weren't in the zone of add a node because of high load, tear down a node because of low load. You could roll code around, but the expectation was typically that you didn't. So if I wrote some Java code and I injected it into the system and it did a thing, and there was a class associated with it, and I wanted to hack the class in my editor and then leave the same system and throw the same class out again, I didn't have a good strategy for replacing the same class. I could append a bogus number on your class and throw it out there as another new class. and
Do you
hope
have
that the
opinions
GC would
on
eventually claim the old one.
systems that allow you to replace code at different scopes? I can replace just this one function, or I can replace this whole class, or I can replace.
Java says whole class, but I can't really replace, but I can age out an old guy and bring in a new guy with a similar name. If I roll your class loader, I can say same class name, new class loader, same as the old one with just an increment on something stupid. And then the GC eventually reclaims the old guy. So there is kind of a way to do it in Java. It's you get more screwing around than you'd like.
Most of the companies I've worked at were these microservice architectures.
Yeah.
We have roughly half as many services as we have engineers.
Right. Oh, I figured you'd have 10 times as many services. Every engineer makes 10, right? Fine.
But one of the things that drives you to that model is you want to be able to incrementally update small pieces of the system.
Yes. So as
I
long
don't
as your
want to turn
version
off
compatible
the
on your
entire
project.
company and turn it back on again at midnight because we're doing an update. You
Yeah.
want to be able to
Right.
stand up 3 instances of version n+1 of the service and then shut down the 3 instances of version n-1. And
Right. Right. And as long as their versions are compatible, whatever quote compatible quote means, nothing breaks.
Right. So there's an interesting question of, can we get rid of the distinction between microservices and monoliths and say, we have this giant scheduler that schedules work all over our cluster, and the scope at which you do a replace just depends on what the scope is that you just called to replace.
Yeah, Unison does that. Unison explores that, and it can
Unison.
dynamically.
Got a link?
Unison? I'm not
I'm
familiar
looking
with
at
that.
Unison
Conway's
programming language. So.
Oh.
Yeah. Unison.
Yes, I have seen this before.
Yeah. And it's actually quite clever idea.
Right. So like Erlang was pretty good at replacing pieces of it without you having to decide at design time what the scale of the piece you want to be able to replace is. Because they had their little supervisor trees where you're like, I can update the thing that is a phone call runner, or the thing that is the manager of a bunch of phone call runners, and you just pick a layer of the tree, replace that, and everything under it.
Because there has to be a channel communication somewhere between parts, and that has to be identical. But if you have a whole tree that internally has some complicated, but at the root of the tree there's some very simple channel, and you replace it with a new simple channel.
Right. Okay. And things didn't change, you just replaced the function. Yeah. So if there was an ongoing call, it's just sitting in the loop routing the call. And the next call that connects will call the new version of the function.
Yeah, it will just.
And the ongoing call will keep running the old version of the function until it returns.
Right.
And then it will get the new version of the function.
Yeah. One thing that I see that would be eased things is we'll have to standardize function call chains as a own entity. So not a version 1 of your software, not a version 2 of your software like a whole package. A whole call chain has a version 1 and a version 2 and a version 3. So that would allow you.
What I heard, the supervisor tree was you had a cutoff point with some root in the supervisor tree, which would look like a function call, kind of.
Mm-hmm.
And you
at any boundary.
it, not the whole set, just the one tree point, right?
Mm-hmm.
So this is what Hotspot does when you JIT a new version of the code. There's an old JITted version and a new JITted version, and they're faster or slower, they do better, whatever. The prior call to the old code continues to run.
What happens if one thread is in the middle of a call to a for loop at the same time that you've just JITted the for loop?
Yeah, the one thread is running the code it was running and stays running that code. It hangs around. So suppose it's running an interpreted loop. It's too easy. Your interpreter example is too easy. So running JITted code from C1.
So let's use the example of something gets invalidated. I made an assumption that a thing was a constant because it's a slow-moving piece of data.
Yeah, and it changed.
And then after 2 weeks of being up, the value changes. And you go, oh, I assumed this was never going to change ever. I invalidate all the code.
Right. So
what happens?
The guy who is running in the code, so it depends on, there's layers and layers here it goes through, depending on where you kill the thing. So in the case of a guy where I assumed a value like was never not null. I only ever saw a null there, and today I see a null, and I have to do something different. So the existing guys who ran through and tested a null from the past, they were fine. They tested already, it was done, it was null at that time, they're good, they have no issue, they carry on. The new guy who comes through and says, oh, it's null, he jumps to a deop and unwound his state, became an interpreter and profiled, and eventually he gets some new code and he's going to jump off to that. So
But that
in
would
these
mean
situations, like,
that
so
would
I have
mean
a
that
class, the bad
so
case.
yeah, that would mean the interpreter is always doing the right thing
Yeah,
because it
you
doesn't
have
do
you have a backup
optimizations.
plan, which
So
is it always does the right thing slowly. Yeah.
yeah,
And then the backup plan also gets you back into the fast case after a little bit. I mean,
yeah.
it jits after a while, and then you're back to the fast case. So the worst case scenario that Hotspot deals with is I had no subclasses on a class, and because it had no subclasses, a call was not virtual, so I inlined the call. The inline call had components that were loop invariant, and I hoisted them out of loops. Now I have a long running thread in a tight loop where he has loop invariants that he's using from the function call that got inlined and loop invariant split out around the thing. While he's spinning along, somebody loads a class. Somewhere in here while he's spinning, his assumptions that he's getting from the prior guy become invalid anymore. And he's in the middle of this hot running loop. This is like the example you're looking for. That's the one where we deop the dude. We force him to stop at the next safe point. So we look through the code for
Okay,
the
so
safe
he will
point.
keep working under a false assumption, but not for very long.
Yeah, we block the loading of the new class. We have a subclass. The subclass says, I'm going to extend some class. That class says, somebody JITted code that said no subclassing. Okay, so now before we let this class load, we go look at the JITted code, right?
So he doesn't work under invalid assumptions. He just blocks the change in the state to the world until
Yes.
such time as he can posit a save point and it's
Yes.
safe to make the change.
Right.
Because the change itself is non-deterministic, it can happen at any time.
It can happen at any time. Yeah.
Right, it's racing with a thread anyway.
So I will block the new changes until I finish, and then I will do my
You
thing.
can't block forever.
Yeah.
So I have a hot
Because
loop
eventually
that
he'll
runs
hit a save
forever.
point.
That's got the wrong assumption, right? You can't block the new guy forever. So eventually you have to go find the thread that's running in this code and whack him on the head. And that's done by demanding that he passes through a safe point periodically, however that long is. You put a flag on the thread saying at the next safe point you will halt. And that's generally done by loading a thread local that's hot in your L1 cache and predictably branched. So it's a one clock cycle every 1,000 clocks or every 10,000 clocks. And he tests and he fails and he jumps out, and now he's told give it up, dude, go to the interpreter or whatever, however your bailout for that dude is.
Go park, the world's changing.
Go park the world. And you can do other things to stop more bits. So I have a wad of code, and I have a bunch of threads that are running through it, and some are spinning in the hot loop. And some threads are trying to get in just as fast as they can because this is the hot code, and I've just subclassed it. So at the start of the function as a safe point, I put a fail out there. I stomp down code. So it's self-modifying code. I stomp down something that says, if you hit this, bail out, you go ask the question, what is the proper JITted code? And he'll tell you, go to the interpreter, I don't have any JITted code yet. So that stops new guys from coming in. When old
So
guys
can
are
I
spinning in this hot
replace a
loop-
class in the middle?
I'm sorry?
Just say, can I replace a class and say, here's this class that has already been loaded, but I'm going to load something else now and give it that same name?
You
Go
can't
deopt
in
anyone who
Java
knew about the old one?
replace a class. You can delete a class. I'm sorry, you can claim no more users of a class, and then it gets deleted by GC. You can bring in a new class with the same name only if it has only if the class loader is different. So the pair, it's the triple of class loader, class name, and security domain is unique, and you can't replace that unique set.
But that's
So
an
if I wanna replace the
implementation
class-
detail. You could have written the JVM such that you could replace that unique set. But you would have to have more watch things on everything because...
Yeah, what's it mean to replace? So this is what debuggers do with hot swap. So what they do is they demand, it does happen. So the JVM halts. I get told, here's the new class. So there is something that happens that gets rid of everybody who's using the old class and they grab the new one. and then you start them up again. Now, people who are stopped have to be stopped in a domain or a space in a way that they can restart in the new code. So if I'm in some old code, this is exactly the problem we're just talking about. I'm in some old code. I'm spinning in the hot loop. You say, I'm replacing this code. It doesn't have this loop anymore. This code just doesn't exist. What's this thread doing in the new code? It has no mapping. There's no, you can't do it, right? So he finishes out the old code. Now, I want to JIT a new function, and I'll swap a new function in, but the old function will live while thread's spinning in it.
Yeah,
If he's
but
correct, the JIT in subclass,
That does sound very similar to what Erlang did to solve the problem of any piece of the system can be replaced. Any function can be replaced at any time.
So the JIT version is from code to code. Doesn't have a natural boundary? Let's say a function, replace it with a JIT function with the same entry point. You just replace code with the new code, with the hotter code, with optimized code. Yes.
You're talking about what Hotspot does, or what?
Yeah.
When the new code gets replaced, what it really means is that new callers of that named function get the new version of the function.
So
the old callers, they're still going.
It is a JIT version. The function has a natural and the JIT function.
There'll be several JIT versions of any piece of code.
But does it have a natural boundary, like a function call? Like where does it decide to replace the?
Yeah, so that's where you JIT. There's a bunch of places you replace at, but actually the main one, the obvious one, is some function header is the new entry point. So what really happens here is I've modified some stupid thing over here, or I've added a subclass that does some stupid thing. There was some top-level function that inline, and inline the old stupid. Now it wants to go to the new stupid. Okay. I got this wad of giant code that people are in, and they're in every possible place in the code, running as fast as they can all through it. So I need to change so that new guys see the new subclass and not the old. So I start lopping off ways you can get to the code. So I cut the header, no new entries. Old guys are still running. Some are in hot loops. I safe point them, and they have to bail out to the interpreter so that the virtual call that had been inline and JIT and blah, 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 now goes to the new virtual call, right? Then there are guys who took a function call, went in deeper and deeper and deeper and deeper, and this is you're stuck on the stack somewhere. And when they unwind, they'll come back up to the wrong state of the universe. So
you have to wait for old function to be out of the stack before you can swap it.
Well, what I'll do is I'll go to the old function that's on the stack. I'll edit your stack and smack your return address. So return address programming, however you want to do that. So when you unwind, and you would have unwound into the old guy, you would instead unwind to a JIT's like little catch thing that says, oh, you're screwed. Go deopt into the interpreter and go figure it out from there. And then one of those unwind paths that we did differs which strategies is we just NOPS, we call it NOPS sledding. Once there's no one running, like the safe point has cleaned all the guys actually running code, we NOPS sled it. We just wipe it out to NOPS. And if you return into it, you return it to a NOP. And it's all NOPS to the end, where you then jump off to the interpreter. So NOP sledding was the easy way to get that one. We did stack editing on some machines and NOP sledding on both and whatever.
And eventually that NOP sled will get GC'd when there's no pointers left.
Yeah, and then at some GC cycle, we'll recognize that no one's in this code anymore, and we can actually get rid of the code. But the code will live on in case somebody was blocked by the OS and suspended within the clock cycle of returning into the middle of the code. Right? So that thread has to hit a safe point. He won't be at a safe point if he's in the middle of a return. And so you have to force that thread to a safe point, which will, as part of the strategy for the GC, he says all safe points, he'll force all things to get idle enough that this random thread, so I got 1,000 runnables and 10 cores, so I have 100 to 1 oversubscription on my CPUs. Some poor CPU got put to sleep thread got put to sleep by the OS forever and a day, and it never makes forward progress because Linux only has forward progress on some small count of threads. And so this guy is just never making forward progress until I force it by putting to sleep everybody. And then the OS is like, I've only got this one dude left. I guess I'll let him run. And then he runs, hits the NOP sled, balls to the end, hits a safe point, bails out. Safe point counter goes down. I'm safe pointing every thread. I'm good to go. I go look, I count people. Hey, no one's using this code. It's GCable now, blah, blah, blah. So
I think it'd be interesting to try and build developer tooling around that for the deploys to say.
Yeah.
You
I can't
changed some
tell.
code in GitHub, it got merged. I'm gonna run off and update the running system, but only the piece that changed.
Yes, that's what we're doing. But we're doing it so that the existing guys ran to completion to correctness, some correct state. Then we declared we're at a Java execution machine, Java bytecode execution state on all threads. They're at some interesting point. Now you do a swap in for some new code. There's a well-defined semantics for that swap.
Yeah, keep the last two commits JITed, so you can switch dynamically between your last two commits.
And then there's optimizations and all these things. Like the JIT cost was actually small relative to everything else. Like the engineering cost to get this correct was a nightmare and had huge counts of people involved and took forever.
It's a huge engineering cost, but I do wonder if this slightly different deployment model could drastically reduce the number of services at Fortune 500 companies.
Well, how do you?
Because suddenly you don't have to make a service for everything just so that you can deploy independently.
So I think what Aaron is saying, you have the service that it will load new code, it will load new Java bytecode.
So this would be, I have a class loader. I know people have these things that shows up in some big app servers of yore that used to do shit like this. I have an app server. He has an app. It has a bean or whatever the fuck is it. And under the code, under the hood, there's a class loader and a class, and I'm hacking. If I hack a new class and I want to inject it, the class loader gets a version internally bumped. It becomes a new named class loader with the name +1. You hate these names. You don't like them, but you don't see them, so you don't care. Then the code gets loaded. Next guy hits the new guy. Old folks finish out. The old class loader runs out of people using it. He gets GC.
Yeah.
This strategy's been around before.
Because when I think about
implementation sucked or not,
most of the services that I see, this is kind of a hand-wavy oversimplification, but not a terrible one, is essentially there's a table at the back, and then there's a library that has a call API that makes changes to the state in the table.
Yeah.
And then there's the users that call the library to read and write state change to the table.
Right.
And in between the user and the library is an HTTP call. Because I want to be able to replace this library at my leisure.
Right.
And I don't want them hitting the table directly because now their code won't be updated until they redeploy after I change something in my library.
Surely.
So in order for me to be able to update my library behavior that sits between my customer and the table, I run a service that's just the library that sits between the customer and the table.
Right.
And the cost of that is I'm now on a different box, an HTTP call away.
Isn't there a microservice model out there somewhere where I can have the model local?
But what I want is for that thing to be inlined into their service. And when I change my library, just call all the JVMs in the company and say, here's the new version of the library. Reload your guys when they hit save points and swap around, and people are like, oh my god, that's changing behavior in the middle. And you're like, no more so than redeploying your service.
No more than, right. Yeah, it's no more than what you're doing already.
So to
answer
if the
JVM
question,
has the hooks to do that, then we could come up with a good deploy model for Team A owns this library and can deploy into all.
Okay, wait. It's had those hooks forever and a day. And I swear I've seen people say I have a microservice that can either be across a HTTP wire or can be local. And if it's local, it skips the HTTP overheads. And then how they implement from there, I don't know. But it's certainly possible you could implement such that the JIT could see through the generated code and just JIT across the line. And it would be fine. And when you deploy the new version, all the old ones would do the old thing and the new ones would do the new thing.
So in Bach at Google, we have something called Bach, which kind of has nodes, and there's what's called a service node, right, or executable node, and then there's what's called a composite node, and that is exactly this. If you put multiple executable nodes in the same composite node, they can talk locally.
Yeah.
If you take those same executable nodes and you put them in different composite nodes or servers, then they talk remotely.
So it's just gRPC, but it's either HTTP or function calls.
You want the local version.
It uses something called Stubby, which is different than gRPC because we have the fancy version. But yes.
You want the key thing here for the JVM at least is to have the local version be thin enough that the JVM can see through it and guarantee inlining across the service boundaries.
So they don't do JIT, but like it all does get compiled in. Like if
Yeah.
you put the services in the same composite, they get
Yeah.
compiled together, and then they can like it's not necessarily going to fully serialize things because like you can only composite nodes of the same language. Like you can composite C++ nodes together or Go nodes together, but you can't like.
I want to ponder the I can JIT across the boundary, and does that make a difference enough in performance that it makes it worthwhile as a enterprise level management strategy? Your thesis, Aaron, was, hey, this would be better. Okay, well, it's been around forever and a day. I swear there have been microservices that have this local remote, and okay, Google has them, certainly. Okay,
Right.
now,
My thesis is this is better because now it's the library that's in the JVM and all jitting optimizations apply.
yeah, and you get performance only if the library doesn't do a handful of stupid things, which it could do. So if in the end the library says, I just make a virtual call, and the virtual call has only one target that it ever comes through, except when you change version numbers, then yeah, it should fold up.
I have seen that hide behind interfaces. The interface has a remote code and
Yeah, so the interfaces are more difficult to inline through because more things have to be correct.
Yeah.
A class that is a class loader class pair, and I throw in a new class loader class pair, and somebody fetches the object and then makes a call through it, like a what do you call single abstract method function out of Java land, right? If they're doing that strategy, then the outer loop wants to get rejitted where the SAM got loaded and the function got loaded out of it, but those should optimize up. And then your hot inner loop with its vcall should say it's the new vcall to the new target, and I only have the one target, and therefore you should get jitted new code.
And how is the process of deploying that usually done?
Well, you would say, I throw you out a new class loader class pair, so a bean or whatever the fuck. I threw out a new one. And the call has to start by saying, I go to the bean and I pull up a thing, an instance out of the bean, and I make a recall on it. And the new value I pull up, the new bean I pull up is new. And so the vcall goes to a different target. However, that path is itself hot enough that it gets its own jitting strategy. That is, I have a hot method that called the old copy of the bean, and it was hot, but it had a vcall in the hot inner loop that got inline because I only had one target. Okay, now I make two targets, and I never ever see the old one ever again. And I get a bimodal distribution, or get a trimodal or whatever. It's bad. Somewhere I want to trigger the reevaluate the situation on this far outer loop, such that when I load the bean for the inner loop, I only see the one new bean, and there were no other instances of it. There were no other subclassings of it, and I want to optimize for it. And I swear this is doable. If you have the code shaped right, it should just happen.
And the way they discovered that said new bean exists is just they had some listening port where someone called them and told them.
No, it's stupider. You get the new bean and you throw it into this global place. And the other thread on his next go round, his semantics are load up from the global.
Right, but you have to know there's a new bean to go get somehow.
That's how he knows. He every cycle through he grabs from a global and tests to see if the global is what he expects. And when it's not,
that's what's happening inside the JVM.
Yeah, inside the JVM.
But I'm picturing like someone did a git commit, CI/CD tested it, decided this was a fine new version of the library.
Oh, I see.
Decided to deploy.
Yeah.
Now your CI/CD pipeline needs to start calling JVMs and say,
you have to push
here's the new library, here's the new library, here's the new library, here's the new library.
You're pushing the new library out, or the JVMs are pulling periodically, whatever. You have some strategy to load the code.
Yeah, you've got deploy bot that calls around.
The JVM, the design strategy is something like, I made a new instance of the brand new guy and I stuffed that pointer. Now all the running threads on their next go around find the new guy.
I updated the global that they all jitted under the assumption would never change.
Right.
because it's a
And you want to
slow-moving
force
value.
them to reassume shortly after the last guy clears out, they can safely assume that they can reject the new guy. Yeah.
But that is slightly
Yeah, it does
different
seem like all
than
the
just
infrastructure's there.
that is slightly
There's something
different
for me
than
to go read or a talk for me to listen to of someone who's tried this.
I don't have anything like I swear I've seen these being local microservice things, but I don't know. Certainly Cameron's ecstasy on a JVM has this strategy completely baked in because he knew it could be
Yeah, I'll go
done, and
Google it
I knew it could
afterward.
be done, and so okay, that's enough heavyweight to say it can be done.
Right. Ecstasy, I think, takes this very seriously as a service
As a
architecture.
go-to, yeah, yeah,
I suppose that's one argument for what I should do to understand this pattern better is just go
right.
read the ecstasy docs.
Well, if Twitter wants to come, pay me money to consult for them for a little while, I always take consulting dollars. If Elon Musk wants to share me some of the money he's spending on Grok, I'll happily slow down Grok development. You
Not
just
Twitter anymore, LinkedIn now, but
okay, LinkedIn. Okay,
new
fine.
social network, same problems.
Same problem. Yep. Yeah, I do it for LinkedIn too. It's all good. All right.
I hear Microsoft has some money at the moment.
Oh, Microsoft. I thought they were having issues. Like Windows 11 sucks and everyone knows it, and now Microsoft's paying the price.
No, it's fine. AI is going to do the whole economy, so.
Yeah, that's right. Well, then we don't need people anymore. We'll just get rid of the people and let the AI do itself for a while. Yeah. There's some giant. What was that famous sci-fi novel about the coming implosion point? Future Shock or something?
About the singularity?
Future singularity. Yeah. I want to say Future Shock, but there's something coming on here like that. Yeah. It's not here yet.
we'll wait for it.
Seems plausible. So the gig economy will implode with self-driving cars. I want to see if self-driving cars can make it to my driveway. The roads being what they are. They get blocked in the middle of the road because they refuse to go forward, and somebody wants to get home. They'll just shove the sucker off the road, and he'll go down a 45-degree slope and never be seen again.
Yeah, I was talking to someone who's one of the AI people at Waymo, who was like, the thing you have to understand about Waymo's numbers is that you should never look at them outside of context. Because on the one hand, if you just say accidents per miles driven, it's a 50th of a human driver. And people keep writing the news stories. They're like, Waymo's 50 times better driver than you are.
Yeah.
And he's like, we are doing very controlled experiments and only deploying in places where we know it works. And they park if it gets too rainy or too snowy.
Or too snowy or too much disaster, this and that. Yes.
And he keeps being like, don't get me wrong, it's miraculously impressive, but also
yeah, right.
The diversity of things that a human can handle is crazy.
There's this theory that says the next large disaster, the big one hits, San Francisco, and things shake and shit breaks, and all the Waymo cars stop in place and block all the roads, and the fire trucks can't get through. And you're like, that'll happen once, burn half the city again, 100 years after the last, burn half the city, and then there'll be a hard look at what you can do with these kinds of, in an emergency, what the hell?
The fire truck will have a way to tow the Waymo cars.
Maybe they have a cow pusher on the front that just push the
they shove it.
off the
They shove
sidewalk.
them.
My favorite video is from the testing that I think was happening in New York. And there was some event that was happening at the Met.
Oh, dear.
And they've got two people directing traffic in front of the Met instead of using the traffic lights because it's this event and there's a lot of people there.
Yes. And the Waymo
but because
cars
of something about the theme of the event, the people directing traffic are in full long coat tuxedos.
Okay.
And are breakdancing.
And they're directing traffic.
Yeah.
Excellent.
So the car pulls up and sees this guy in a tuxedo with long coat and says, "Oh, that's a pedestrian," so it stops.
Yes.
And then he's telling the person to stop and he goes, "Oh, that's not a pedestrian. That's a traffic director. I should wait for him to wave for me and then I'll go." And then the guy reaches back, catches himself with one hand, and then waves on the Waymo. And it
Yes.
just looks at this person who's leaning back on one leg and one hand, waving him forward, and just declares bankruptcy and is like, safety driver, take over. I don't know what to do with a break-dancing tuxedoed man directing traffic. Which again, none of the humans had a problem with this. They were just like, oh, the Met's doing
I
the
would have a
thing.
problem with that. I would
would
have
be
a problem
entertained,
with
but I
person
would never have a problem.
laying down on the road telling me to go. I would have a problem with that.
I would be amused, but yeah, I would
Yeah.
never have a problem. So I
You know,
always thought
humans
that
are just very flexible
I
in a
thought
way
that
that, you know, compilers really want you to be rigid.
yes. I always thought the fail mode would be people would run out with traffic cones, capture the Waymo cars, and then just steal them.
Yeah.
Just
Yeah.
take
Why
them,
not?
take them back to the shop, chop all the
Yeah.
cameras off, turn around, sell it on the African market for $100 a pop. Something stupid, right?
That would be a crime.
It would. And you're telling me there's no crime in New York City? Or San Francisco or LA? No, come on, what the hell? Fine. Use a cheap enough car with enough cameras that maybe people aren't interested. I don't know. I put my ICE agent uniform on and I go block the car off and drag it up on a flatbed tow truck in 2 minutes, chop all the cameras off while I'm dragging it into drag it inside of a Faraday cage so it can't call for help. And then I drive it back to my chop shop, take it apart, sell it in Africa for $1,000. We make some money here. And, you know, you got hundreds of pictures of guys in ICE agent outfits and all your cars are disappearing to Africa. That's
Okay,
what I
you
thought was
pursue
gonna
that
happen.
business model, I'll write some code.
Yeah, right. Well, that's not my business model, but that's what I thought would happen. No. Fine. All right. I want to be done. I have things to do and lunch to eat and all that kind of stuff.
All right.
Entertaining.
I'm gonna go keep thinking about how to do capability systems for agents, but
Yes. Like I said, you know, if you want to pay me some consulting dollars, I can come talk to you about it.
I thought it would be easier to chop off all of the bindings to OS syscalls from programming languages.
Um,
The ability to just say, I want Python with no file system access and no network
you
access
gotta
and
pick
make
your
all these
battles.
things go away. And
Well, no, you can have any of these languages that do that as long as you can validate that the execution thing you're going to run. That's one of the issues with Java bytecodes, or one of the strengths of Java bytecodes. You can validate that the program text doesn't call system.exit, doesn't call random evals, doesn't call whatever the hell you want. Whereas if I hand you a binary, I have no idea. How do I validate the binary is like not cheating?
right, so
right?
that's the problem. JavaScript, and
Well, WASM.
WebAssembly
Yeah.
are relatively reasonable things to go chopping off the bindings to.
Yeah, right. Then yes, you have to give up
Python
on.
goes into C code
Yeah.
everywhere. The
Well,
amount of stuff in your typical Python program
yes.
that relies calling out to C,
Haven't you learned by now not to use
Python's just a
Python?
fancy way to call C.
Just say no.
See, that's what I was thinking earlier when you guys were like, all these things with running out of memory bandwidth. And it's like, mostly I've been writing Python lately. I never run out of memory bandwidth because I've got plenty of time to do the memory fetches while I'm doing all of the interpreter loop lookups, because
but
every
much
single
sooner.
instruction I have to go back to the interpreter loop.
Right, where you're running the fucking amazingly slow interpreter loop. All right, fine. No,
If you just run a slow enough language, you don't run into any of these problems of
Good
saturating
point.
your memory bandwidth.
Good point. But I'm still going to be done. All right.
Right.
Till we meet again. Bye-bye.